Already mentioned. Okay, so my topic is that machine learning based power system voltage stability assessment for distribution system. So before going to start our topic, we have to know about what is voltage stability and why it is important for the power engineers. So voltage stability means that we have to maintain a acceptable voltage limit to our all the buses during normal conditions as well as even in disturbance conditions also. So the main reason behind the voltage instability is the lack of the reactive power reserve when there is an experience of heavy loading. Hmm. So this is the main reason. Now, if you see the if you see the loading versus voltage for a particular bus in a power network, you can see if you have more number of more power taken out from a particular bus, then our voltage level is reducing. And you see that after some level of the voltage, we are coming after some operating point, we are coming some kind of critical region. And after that only what happened? The system become collapse. So this point is referred as a knee curve, knee point of the PV curve. And before that knee point of that PV curve, we have to know about that this situation which is arising for the system. So for that we need some kind of alarming things, and a power engineer should have some kind of that informations such that they can take some measure before the system going to be collapse situations. So that is this time, this particular operational time is referred here, some margin referred here in the characteristic curve by some marginal part. Okay, so before coming to the knee point, we should have some kind of you know that that uh, we should have some kind of time in our hands such that we can take a measure. Okay, so now you see for a particular system, if we or a particular bus in a system, if we are increasing the load, what happened? You see the voltage level is reducing, and after some time the particular bus become very stressed and the system become collapse. So here by this figure only we are showing that things. You see that initially when number of bulb is increasing or number of load is increasing, then for a particular bus, you see the operating point is just lowering. That means the voltage level is lowering, and after some time, some blackout is there. And if we are not considering it for a particular bus, later on there will be some issues, some cascading failure will be there, as well as the overall system become collapse. So whenever we are talking about the voltage stability issue, due to that one, there was a lot of incidents across the world, and among them, some of the things already been cited in previous researcher in their papers, like in 86, in the year of the 86, in Brazil, they are having some kind of issues like that in South Florida, then Sweden, then France, Tokyo, Japan, in everywhere such kind of phenomena was happened. Even in India also, just few years back also some situation was there. So due to that one, we have to have some kind of correcting measure, and we have to have some kind of you know indicating measure, such that whenever is a system is going to be collapsed, before that one we should have some kind of information, and based on the information we should take some correcting measure. So the main way through which we can minimize this kind of voltage stability issues, or we can resolve these issues by many way, like that if you utilize more number of loads, then what happens, there will be some more active power loss as well as some more reactive power loss in the system. And now, not only loss, that whatever the generation of the active power as well as the reactive power by the generator, if we are utilizing more than that one, then there will be some power imbalancing, active power imbalancing as well as reactive power imbalancing. If such situation will arise, then what happens, then this stability issue, if the reactive power mismatching will be there, then there will be some situation for voltage instability. So if we have some kind of options to reduce our load, that will minimize the stability issue. Then if we have some kind of options with us to introduce the reactive power support, particularly leading var, whenever some kind of reactive power mismatching problem will be there, we can introduce some kind of capacitive var. Okay, so that is also one of the solution. And nowadays, we are utilizing the fact device like SBC and STATCOM, which can also inject the leading var as well as the lagging var as per requirement. So that can also serve the uh, solutions. Okay, so along with that one, we can improve the voltage level using the tap changing transformer also. So these are the methods, conventional way through which we can improve the conditions which is having the voltage stability issues. Okay, so but apart from that one, some network reconfiguration, nowadays people are also doing the same solution using network reconfiguration. This network reconfiguration is a way through which they are changing the structural part of a power network. In a power network there may have number of series switches as well as some of the parallels. That means sectional switches are there as well as some tie switches is there in particular distribution side. By operating that switches, this overall structure of a network can be changed. And based on that one, the overall active power loss as well as reactive power loss can be modified. And by that only, the stability problem can also be solved. Voltage stability issue can be solved. So now these are the some things, like we can use on-load tap changers for utilizing in distribution side. Okay, similarly, we can use this distribution transformer for for voltage regulation purpose also. So these are similarly, these are some capacitors we can utilize for injecting the reactive power, leading var to the system, like series capacitor, shunt capacitor, we can utilize in the system. And similarly, these are some pack device which can utilize for mitigating the voltage stability issues. And nowadays, as I told you, particularly for distribution reconfiguration, we are having different type of switches like sectionalizing switches. So here some particularly ABB made sectionalizer is there which can be utilized for network reconfiguration purpose, as well as you see recloser, similarly fuse. These are the things which can be utilized for distribution level for reconfiguration purpose sometime. So now the question is that, the we are thinking about the nowadays for distribution feeder management. Now, why it is required? Previously, our grid was completely run by, conventional thermal power source or thermal generating source only or nuclear like conventional sources only. But nowadays we are introducing the renewable sources to our grid, and whenever we are introducing the renewable source that are very intermittent in nature, that means you cannot predict that what time what kind of power you can get it from the renewable sources. Like if we have some PV cells, if we have some windmill, how much power the that renewable resources can deliver for a particular time instant. This is very unpredictable things. So sometime you may get more, sometime you may get less also. So whenever you are getting less, that time some kind of if you want to run the whole things by assuming that you are getting some amount of power from renewable sources, it may not get the same amount of the power. So that is why what happens, some kind of mismatching will be there, of the power mismatching will be there. Sometimes you may get more beyond of your expectation also. So that is why some mismatching will be there, as well as some reliability issues will be there. So due to that one, we should have some provisions to control this power, and for that purpose only we may utilize some kind of reconfiguration techniques, as well as, and whenever such situation will arise, definitely some voltage stability issues will be there, and that issues may be solved using some kind of feeder management technique for a particular distribution site. Similarly, you know that nowadays we are very much interesting about electric vehicles, and for charging purpose, this electric vehicle part, we are introducing many charging stations in the distribution side. And whenever you are adding more number of charging station in the system, what happen? Then the loading also will be increasing, and as a result what happened, the transformer also be overloaded, and other circuit, other things also will be overloaded, feeder also will be congested. So to manage such kind of things, we need to have some kind of feeder management. So now, normally, what we are going to do here, basically in a power system we are trying to maintain the system such that it will operate at a higher voltage level. Particularly, we have to maintain voltage stability here, and we have to minimize the transmission loss, as well as normally distribution side we have to operate it in radial. But here for the present discussion, we are concentrated on particularly voltage stability part for the power network distribution. So now, as I told you, the reconfiguration, that reconfiguration means the restructuring of the power lines which connect by the various buses in the power system. Restructuring of a specific line lead to a alternative system reconfiguration. System reconfiguration can be accomplished by placing line interconnection switches network Opening and closing a switch connects or disconnect the line to the existing network. If there are n switches in the network, then there are 2 to the power n possible switching combination will be there. So you see that particularly reconfiguration means what is that? Why we are talking about reconfiguration? Because we are interested about to improve the voltage level or voltage profile as well as the voltage stability for a particular distribution site. So now whenever you are thinking about for distribution side, their feeder management is one of the important aspect. And that feeder management normally can be done using the reconfiguration. Now, this particularly feeder line is connected between two nodes, and in each of the feeder there will be one sectionalizing switch, and between two feeder there may have some parallel connections, there may have some kind of tie switches. If we change the status of the switch, the overall structure of the feeder can be changed. And as a result, what happened? Overall system stability can be increased. Some of the configuration can give you the better system stability, some of them may not give. So using that reconfiguration technique, finding the particular one optimal network for which we are having the higher voltage stability or higher voltage level system, that is one challenging task for power engineer. So in this aspect, that power engineers are nowadays utilizing different techniques. So normally these are the different outcome for power network reconfiguration, like they can improve, they can relieve the overload in the power lines, balance the network loads and optimize the voltage profile. They can enhance the reliability, reduce the losses and load balancing and planning, as well as they can do the service testation. But in the present study, we are concentrating on the voltage profile optimization part. So now I am just describing about the network reconfiguration part. Let us consider we are having some kind of network. This network, this is a 6-bus network, and the network is connected by some feeder lines, and each of the line you have seen that some of the switches are there. Now opening and closing switches will give you a particular reconfiguration. Now suppose if this system having say 9 switches or 15 switches, then we may have total 2 to the power 15 minus 1 possible configuration. Now by each of the configuration, means by each of the switching pattern will give you one of the reconfiguration. So now in the present study, in the present discussion, I have to show you that how the reconfiguration, through reconfiguration, we can assess the voltage stability using some machine learning technique. So now the thing is that, you know that as I told you that we are having total for a particular small system, you see for 6-bus system, we can have 2 to the power 15 minus 1 configuration. So 2 to the power 15 minus 1 means 2 to the power 10 into 2 to the power 5. So 2 to the power 10 means 1K, and 2 to the power 5 means 32. So total we are having 32K number of switching pattern. So from that huge number of switching pattern, if someone wants to find the voltage stability for a particular one pattern, he cannot find easily. Okay, so now for this purpose, if he can utilize some kind of artificial techniques, artificial intelligence technique to determine the stability for a particular pattern, he can easily do it. But if you do using load flow technique, it will consume a lot of time. So for that purpose, we are utilizing some kind of machine learning technique. Okay, so when we are going to do any kind of intelligence technique, we may have different steps. What are the different steps? First of all, you have to make some data set which can utilize for training purpose of the machine learning. or your artificial intelligence. So now, so to make such kind of data set, we need to do some kind of load flow analysis. So using load flow analysis, you have to find out some stability indicator. And with that indicator, you may have, you may have some target value. Target value will be your indicator, and your input will be what? Different, different switching pattern. So by different switching pattern, the you have to generate the stability indicator value. By that data set only, you have to train your artificial intelligence model or your machine learning model. So now, you may nowadays, by researcher, they have developed so many indicator like voltage stability index for a reduced single line equivalent model, or VCPI indicator, DQ sensitivity indicator, L indicator is there, PV curve bifurcation analysis is there, so energy function analysis is there. Now by using any of the technique, you can able to determine the stability indicator. Using that one, you can able to determine the stability indicator or your target value. And for different line configuration, different network configuration, you can able to find all these any of the indicator, and based on the data, you can able to do some kind of, assessments. Any of the configuration assessment, voltage stability assessment, you can do. Now for here, for the case study purpose, in the present discussion, we have considered a 33 node system. And in this 33 node system, see, we are having total 33 buses, and we are having total number of feeder line or branches is 32 bus. And here the bus voltage level is 12.66 kV, and bus 1 serve as a slack bus. Uh, and this is and we are having the load of 3655 55 kVA, that kilowatt load, and 2.260 kVA load is there. So now, after using ETAP, we have made some kind of load flow analysis, and we have utilized the Newton-Raphson method. And after doing the load flow, we have calculated the L indicator. And for different switching condition, for different pattern, for different reconfiguration, we have calculated the L index part. So so now, by using that one, we make some kind of data set. And after that, after making that data set, we have utilized some kind of some kind of machine learning model. So in the machine learning model, there are different types of machine learning model are available. Like, regression model is one of the most known model. So in our analysis, we have utilized some kind of linear regression model. So this regression model basically is very simple technique. We are in that we should have some kind of dependent variable and some kind of independent variable. And the dependent variable is referred here some kind of target, and independent means their feature only. So now, we have to calculate, first of all, using that one, using this model, we can, if we have some kind of input data and corresponding some output data, if we have some a data set, if you have a data set, now from that data set itself, we can make some kind of regression model. And using that data set, once if we made the model for any of the input value, we can any of the unknown input value, we can easily determine the output value. For our case, our input variable is what? Different type of switching, different type of switching pattern. By that one only we are given by different switching pattern for different configuration, what would be the voltage level, what would be the L index value, we have calculated. That L index is considered as a target value. And now by having that value, we have trained our machine learning model. And after that, after once the model has done for any of the configuration, you can easily determine the L index value. Now, as I told you, we are having for a for a 33 node system, we are having 32 branches. Then you may have 2 to the power 32 minus 1 configuration. Now, out of that configuration, if you want to find any of the configuration and voltage stability, it is, you can easily do it. But using, if you want to do the load flow solutions, and if you do if you change the switching status of a network, and if after that if you do the load flow solution, after that if you want to find the L index, it will take a long time. So so to avoid such kind of issues, or particularly nowadays we are utilizing our SCADA system, we are utilizing our smart grid. Now in smart grid, for a particular operation, if suppose a power engineer wants to know for a particular configuration what would be the stability index, he can get it within a microsecond, within a microsecond value. So if you have, if he have that model, very good model, he can easily determine that one, and based on that particular information he can operate the system. So this is the main in objectives of the smart grids, for utilizing such kind of intelligence techniques in power system. So now I'm talking about that linear regression part. So that linear regression means it is a very simple technique only, and sometimes it may be polynomial regression where you may have different variable, and it may be non-linear type of model. Similarly, there are different types of regressions are there, like logistic regression, Ries regression, then other non-linear regressions model also there. Okay, so in this linear regression, basically what is happening, they are following some kind of equation like y equal to ax plus b, where a and b is the coefficient and x is the input variable, y is the output variable. Now you see, if normally in a linear regression we are getting some kind of predicted value, particularly by some kind of linear, if you see some kind of straight line for a particular input which is given some dot here. Now for that our output, maybe it will follow a particularly straight line. Now see, if, whenever we are following that one, for that only we have to mathematically follow that linear regression equation, which is y equal to ax plus b. Okay, so now by using the mathematical analysis, we have to determine the coefficient of a and b. Now how it is possible? Now you see, for a particular if we have some data set which is given in by dot, now you see our prediction value is there. Now every time if we calculate the error between exact value, between actual value and prediction value, if you calculate that one, and after that if you find the difference between exact actual value and predicted value, then afterwards if you make the minimization of the error, by minimizing that error we can get the solutions of the get the value of the a and b, and with this one only we can determine the expression for or that linear equations. So, in our case, we have utilized, say, at a time three switches for our power system network, and so we may have in total 32 to the 32 minus 1 configuration in and you see out of that one we may have some sample small sample of data I have shared here that which give you if you open the switch 1, switch 5, switch 32, switch 10 and switch 15, switch 19, what would be the L index and power loss as well as the Q loss. That data you can easily compute using load flow analysis. So to find out the machine learning model, you need a good data set. So once you are having the data set, you can train the system, and afterwards you can and find the any of L index or P loss or Q loss for any kind of configuration. So mm, so to determine the performance about our model, we have done some kind of we have calculated some performance metrics which can give you about the model information. So here we have utilized some root mean square error calculation, mean square error calculation, R2 square calculation, and mean absolute error calculation. So, in the evaluating of the machine learning algorithm, these metrics are used to assess the model accuracy, precision, and generalization ability of the unseen data. Typically, lower value of RMSC, MSC, and MAE indicate the better performance, while the higher value of the R2 suggests a better fit of the model to the data. So we have to check after making the model. We have to check the performance of the model. So and based on some kind of metrics like root mean square error, mean square error, mean absolute error, and R2 square value. So we did that one. So now basically mean square error means your actual value and your predicted value, that difference square and summation of that one, that will give you the mean square error value. So similarly we can have the R2 square value. We have to find the residual value of the that one, and we have to take the total things. So here we have to take the residual as well as residual means what is that one? That sum of the total real and predicted values of the dependent variable, as well as we have to find total value, total average value, as well as total mean value, as well as the actual value, that difference value. This will these two ratio is an important factor. 1 minus this ratio will give you the R2 square factor. So similarly, we are getting the means absolute value also, absolute error also. So after doing the analysis, we have found that for this particular model, we have RMSC value is 1.138, MSC value is 0.129, and MAE is 0.114, and R2 square is 1. So, so this is about the matrices of the model. So, so this is about one case studies where we have utilized linear regression model to assess the system voltage stability during system reconfiguration. So now I'm asking to the audience, is there any question from your sides? Any questions? Any questions from audience side? Hello. Any questions from audience? Hello. Sir, any questions from audience? Okay. My slide is visible to all of you? Hello.
Sir, it
Sir,
is
my slide.
visible. Now it is not visible.
Okay.
Some problems.
Okay, okay. No, no. Till the last slide was visible. Is it now visible,
Last
madam?
slide.
Just can you see? Is it
Last
visible
slide
now,
was.
madam?
Now it is visible, sir.
Okay, okay. So, madam, from your side, any question? Otherwise, I'll go for the next case study.
Okay.
Is it
Okay, sir. Next. Go to
anybody
next.
have any? Yeah, I'll be happy if there is any questions. I'll happy to give the answer if any questions will be there from your sides.
Someone else. Participants, if you have any question, please ask. I think you should continue. They will ask after the session.
Okay, okay. Thank you. So now I am going for the next study, that is for uh, voltage stability assessment for a system to determine the optimal location of the SVC using machine learning algorithm. So if we introduce the SVC of fact device in a particular region of a power system network, definitely there will be a, an improvement of the voltage stability of a particular system as well as the voltage level. But the question will arise at what location we have to incorporate the SVC. So in the present discussion, what I will do, uh, that we have to check the the location of the SVC using some kind of machine learning technique, and that machine learning technique can give us some information to the distribution network engineers, that if there is any kind of load imbalancement, then which location will be the appropriate to connect the SVC at reconfiguration environment. So this is the present study. So now for this purpose, we have utilized FVSI indicator, first voltage stability index, which can give us the information about the location of the line where the is location of the line from which we can give some kind of conclusion about the connectivity of the SVC locations. Okay, so now the SVC, basically this is static var compensator. This is one of the family member of the fact device, and this can inject leading var to the system as well as the lagging var to the system. Now, in that device, we may have, you know, some kind of power electronic devices, and by proper firing angle operation, we can inject leading var or lagging var as per the requirement of the system. So whenever some leading var required, that time, we are injecting the capacitive var to the system. Whenever the lagging var is required, that time we are injecting the inductive var to the system. So now about the FBSI, which has been taken care for determining the locations for SBC connections. Now, in that SBC connection, I'm just explaining what is FBSI indicator. Suppose if we have the two bus network at bus number for our explanations, here we have considered bus number A and bus number B. In bus number A, let us consider voltage is VA at an angle 0 and bus number B is VB at an angle delta. Now, if I want to find out the current through this line, which is flowing from bus number 1 to bus number 2, that will be VA at an angle 0 minus VB at an angle delta divided by R plus JX. Now, the power which is getting at bus number 2, that can be written by VB into I star. And similarly, I will be, from there we can get it by equation number 3. And we can replace the equation number 3 SV by active power and reactive power. We are having SV equal to PB plus PA plus JQA, PB plus JQB. Then, if we make star, then it becomes PB minus JQB. Please mind here that there is a printing mistake. It should be PB minus JQB, not PA minus JQB. So in equation 4, it should be PB minus JQB divided by VB at an angle minus delta. Now, see, we are having some current expression, two current expression. Now, if we equate that two, which is getting from equation number 1 and 4, we may have some kind of equations. Now, from that expression, if we separate the imaginary part as well as the real part, how it is possible? VABB at an angle delta, that means you have to make VABB cos delta plus J sin delta. Similarly, if you make it, then you can separate both real part as well as imaginary part by comparing left side and right side from the equation number 5. Now, from that expression only, if you take VABB cos delta is equal to, from equation number 6, if you keep only VABB cos delta, and I think here once again some printing mistake, it should be VABB sin delta in equation number 7, then you may have some kind of expression like that. Now from here, please mind it, here VA means V1 and VB means V2. So it is finally been replaced due to some printing error. So now, if I do that square, and finally we'll get VB equal to like that. So now, see, you see VB is a real time value. So VB, this is a quadratic equation. So now for finding, since VB is like that, now since VB is real value, then their discriminant should be B square minus 4AC should be greater or equal to 0. So that formula we are putting here. Now you see, we are putting here delta equal to 0 and R sin delta equal to 0 and X cos delta nearly equal to X, because if delta is nearly equal to 0, that's why these values like that. So from that only, we can easily calculate the value of, FBSI value. So this is about some indicator which is utilized to determine the value of the indicator, through which we can able to know where, if we introduce some kind of fact device or SBC in a particular location, what would be the value of the FBSI. Based on this value only, we can determine whether that connections of the SBC have some meaning or not, have some impact on the grid or not. So this FBSI value is near to 1. Okay. So so the ideal value is you know less than 1. Okay, the ideal value as near as 0, it will be better only. Okay, so now for our system we have done some kind of reconfiguration. So we have taken some kind of system of 14 bus network. In the 14 bus network we are having total 19 line, and 14 buses are there and 19 line are there, and their base MVA is 100, and there were 11 loads, and total power was 1090, and reactive power was total 675, and generation and demand was 1372.76 and 1362 megawatt respectively. Now, our main object was to determine particular configuration which will give you the best impact to the system with SVC connected system for a particular location. So what we did, actually done some we have done some numerous number of load flow analysis, which in the which consist of the load flow network should consist of SBC along with some lines, feeder lines, which should have some sectionalizing switches. Now what we did different configurations, and we have made one data set for different configuration, what would be their losses as well as the stability value. That thing has been determined and data set has been made, and after making that one, we have trained the model, machine learning model. So now if somebody is asking particularly which configuration having for a particular location of the SBC, which configuration having the best impact of the system, we can get it. How it is possible? Now, after making the model, we have once training was over, then what we did, we have to determine the different FBSI value for a particular SBC connections, and and uh, and we have checked the losses. We have checked the FBSI value for different sequence. That will give you the voltage as well as other losses also. So now you see, if we add, we are having some kind of, different SBC at different locations. Now we are calculated the FBSI value, different line FBSI value. Okay, this value, and based on that value, we have trained and different switching actions. We have trained the system for different FBSI, and we did the model using gradient boosting regression model, linear regression model, and k nearest neighbor regression model. So here we have utilized three different models like gradient boosting model, linear regression model, and k nearest neighbor regression model. And after making the model, we have assessed their performance using some metrics. That metrics are MAE, mean absolute error, mean square error, and R2 score error. So now mean square percentage error. Okay. So now after doing that one, we have seen that the gradient boosting techniques, they are giving a better one. Hmm. So so these are the different comparison of the different model. So now it is, now you see that for different model, for a particular problem we are getting different data, means different kind of performance. So you have to, when we are doing some kind of analysis or some kind of estimations or some kind of work, we have to check with different model, and we have to check the suitability of a particular model, type of the model, which model will work for what problem. So for a particular problem or for a particular data set, one model may work, one particular machine learning algorithm will work better, maybe another machine learning will not give the better result. So from this experience we have learned that that is true, and gradient boosting regression model is giving the better result comparing linear regression and other neighbor regression. And now after doing there, we have that verified that thing, that we have checked the ABSI kilowatt and other things. We have seen that for ABSI percentage is 0.33, like that only. Okay. So these are the different model characteristics. After getting that one, we have tested by particular some sequence of the switching. From that only we are getting such value. So so is it clear? Anybody having any doubt, sir? Anybody have any doubt? Hello. Okay. So anybody have any questions?
Participants, have you any queries? Do you have any queries? Then you can please ask our expert speaker.
So if you have any question, please you can ask through. We are having some chat box. You can give your question to the chat box also, such that I can give the answer. Okay. Then I'll go to the next part. So so you see, now after that, after having that model, we have compared that things uh, with respect to voltage profile. by connection of the SBC, we have found that if SBC is connected based on the FBSI value, which is more nearer to 0, then you can see that one curve we have given, when FBSI is connected, that time what is the result is there, and when FBSI is not connected, what would be the value is there. And for particular FBSI, that value, what voltage improvement is going on. You see, when when SBC is not given, the deep line is there, voltage profile is less. And when FBSI is connected, when SBC is connected based on the FBSI, your voltage profile is increasing. So that means here, this one is very, useful technique through which a power engineer for a particular time of instant, or for a particular for a particular loading condition, he may understand which switch has to be operated such that that corresponding SVC can be operated, and the impact of that SVC will be what, and what would be the corresponding FBSI. So first of all, if they are doing some switching pattern, for that switching pattern, what would be the FBSI value, and that corresponds to what SVC is connected, and that correspond to what impact will be there in the system, that can be easily checked. Ah, so it is and that's also can be done within a few seconds, not a big time is required. So this is very important things for smart grid operations. So after connecting that SBC, you see the loss and other reactive power loss also reduce. So previously you see the losses, and now you see the losses. Okay. So so by having the data of the FBSI value using the machine learning, you can choose the switching pattern. Based on that, you can operate the SVC, and that will improve the system performance. So this is about the whole objective of the study. So if we have any query, you may ask me. This is about my first part of my presentation. If you have any question, you please ask. I'll be happy to give you an answer. Anybody have any questions? Madam? Hello?
Yes, sir.
Madam, I'll just need 5 minutes time to share my another PPT. Okay, just five
Okay,
minutes. Is
okay.
it okay?
Sure, sure. No
Okay,
problem.
please give few minutes.
Okay. And by this time, if any participant having any type of queries, you can just share your queries in the chat box. I'll leave for today then.
Welcome to the sessions. So, now uh, I'm talking about the another type of the applications for machine learning for power system security assessment. So now, as you know that the basic structure of a particular machine learning model is like that. Initial level, we need to have some training set. Then we need some learning algorithm, and that learning algorithm will be utilized for training the model. And after that, what happened for after training part, any of the inputs for any of the unknown input, we can able to get the estimated output. Okay, so this is about the basic things about any of the machine learning model. Now, so so here what we are going to do, that whenever we are doing some kind of feeder operations, that time, that many situations may arise. Some cases may give a good voltage level situation. Many cases may not give. Many cases given in between that two states. So now, if we classify all the state, how it is possible? So in this study, what we did, we have done some kind of analysis for a 30 bus as well as the 14 bus network. And after that, we have determined the single line equivalent L index stability for different configuration. And from that different configuration, we have seen that from the data set itself, the L index value is different. And that different L index value we have classified into three different groups, three or multiple groups. And by that data set itself, we have trained the system. And after training this machine learning model, classifier model, for any of the unknown switching pattern for a particular loading condition, if we want to know about this situation, particular situation, particular voltage level, what would be their class, that can easily determine in a very small time. Okay, so I'm just skipping some of the slide. So this is about a single feeder line system, where you see if we have a multiple line, that can be represented by a single line, where you can replace the total load as well as the total equivalent load as well as total equivalent input power, active power, reactive power, and equivalent impedance also. Now, from that only we are getting some indicator, VSI indicator, voltage stability indicator, which is given by that one. And this value is coming normally in between 0 to 1. So since this is a known things and this is already there in our literature, we are not at all explaining these things now. Now, what we did basically, we are checking here. So, so here we have done some kind of, we have utilized some kind of machine learning algorithm like k nearest neighbor and decision tree algorithm for classification purpose. So what we have done, see, we have done some kind of load flow using Newton-Raphson methods, and we have calculated the VSI index for different configurations, and we have given some ranges of the VSI value. Now you see, if the value of the VSI is in between 0 to 49, 0.49. For that case, we have considered this is a normal case. If it is 0.50 to 0.69, it is intermediate state. And if it is greater than 0.70, then only it is emergency case. Now, you may think that this kind of approach is very much essential for a power engineers who are operating the system. Suppose if you want to have some kind of alarming situation, he has to consider that intermediate state. By that time only he have to take corrective action. Okay. And he have to give some emergency alarm when their VSI value 0.70. Now this can automatically control. If we have such information, based on that information, you can give some kind of automated alarming also. So now, see, for different configuration, switching configuration, uh, what we did, we are having total for 14 bus system, we are having total 20 switches. Like S1 switch connected between 1 to S2 1 5, like that. We are having S20, total 20 switches for 14 bus system. And for 30 bus system, we are having total 33 number of lines. Each line consists of one sectionizing switches. Now you see, after having such switches, we have done some kind of load flow analysis to determine the VSI index. And from this data set itself, we have seen that almost 100 data, 100 number of data, more than 100 number of data is coming under intermediate state, and some kind of, you know, uh, mm, almost 50 data was for emergency state, and some data is there for normal state. It is almost 30. This is about the initial conditions. And after that, no, we are having some kind of smooth dish analysis. And after that, we are getting that frequency to manage. You see, these, whatever the things we are getting, these data for intermediate, emergency, and normal, that was actually, that was imbalanced data. And to make it balanced, we have utilized some kind of smooth analysis. Okay. So now, mm, now after doing that one, we have done we have made some data set for 200 data. Out of that, 80% data we have given for training purpose, and 20% data we have given for testing purpose. Now these are some sample data. You see, at different configuration with different switch opening status, we are getting, what is that? We are getting different VSI value. different P loss, Q loss, and these are coming under normal conditions. So what, see, some of the cases are normal, some of the cases are intermediate, some of the emergency. So this is some sample of data I'm showing. What is the pattern of the data, right? What are the different attribute? What is the target? We have given here only. Okay, this is sample of data, but we have this is just only a one, two, just a minute, 1, 2, 3, 4, 5, 6, 8 data is there. Okay, only 8 data, but for our training purpose, we have done almost 200 set of data for different configurations. So now, after training that one, we have checked the performance of our model for the two techniques. One is KNN, another is for decision tree. And to check that one, we have utilized area under curve. Okay, that will, since our data set was imbalanced, so that's why we have taken care. And similarly, we have calculate the ROC also for receiver operating point characteristics. So now the area under the curve explain how the use of the ROC curve achieves the positive and negative distinguishing. So the positive and negative outcomes can be easily distinguished if AUC is 100%. Acha. And there will be no difference between negative and positive if AUC tends to 0. So now here the importance of AUC is that if the area of the curve is more, then our model is more accurate. If the AUC is less, then it is not so correct. So if AUC is 0 means that model is not useful. If AUC is more than 50% or beyond of that one, means 60%, 70%, 80%, 90%, if it is nearby to 100 means it is more accurate only. So now for different threshold value, you see, whenever we are classifying the data, we may have different threshold value. So for different threshold value, we have calculated different ROC. And from that only we have understood that wherever the area is more for a particular ROC, for that only, for that threshold value will be more effective. Okay, so now we have calculated the RSC curve for both, for k nearest neighbor as well as decision tree classifier. So this is the two curve. So for class 0, the area is 0.98. For class 1, its area is 1, and for class 2, 0.98 for, for nearest neighbor. And for particularly decision tree, when we have utilized the decision tree, we have seen that for different class 0, 1, 2, we are having what the area is 1. From this, we can tell that the decision tree is giving better result comparing the nearest neighbor for this particular problem. So now we have been calculated the accuracy, and we see we have done the classification problem, and we have determined the accuracy by true positive, true negative, false positive and false negative ratio. So true positive plus true negative divided by true positive plus false positive plus true negative plus false negative will give you the accuracy value. And from that only we have calculated the performance of the machine learning model. For KNN, we have seen that accuracy is 0.99 and decision tree is 1. And their execution time is 0.7 and 0.3. So this is about accuracy and execution time for this model. And we have make some confusion model also for k nearest algorithm, as well as decision tree model also. Now we have checked the precision as well as recall value to calculate the F1 score. So we have calculated the precision and recall as well as the F1 score for both decision tree and KNN model. For normal class, particularly decision tree model, we are getting all one precision recall F1 score, as well as intermediate also 111 and emergency also 111. And similarly for KNN model also like that only. 1 for normal case, and recall is also 1, corresponding F1 also 1, and for intermediate case 1 9, and like that only. So this particularly, this is some kind of matrices through which we can assess the classifier. So this is about the internal tree structure for a decision tree classifier, where entropy value we have calculated, and gain, information gain also been calculated. From that only we have determined the internal tree structure. And finally we have seen that the training time is a also important part. For k nearest neighbor it will take 80, and decision tree it will take 65 minutes, sorry, 80 seconds and 65 seconds. And for testing time it will take 0 0.7, and decision tree to 0 0.3. So now if you think about the error, mean square error and standard deviation, we are getting k nearest neighbor 0.47, and MSC and standard deviation 0.90. For decision tree 0.001 and standard deviation 0.001. And if you compare this one with NN, it is coming 0.002. So we have compared these things with other existing technique like DFO SVR. It is coming 0.166. Comparing this one, the K nearest neighbor and decision tree is giving better result. So with this, if you have any question, any questions? Hello? Any question is there? Hello?
Dipu sir, your presentation is over.
Yes, ma'am. Yes, over.
Okay, okay. Participants from your side, anybody want to share your queries to our resource person, you can share your queries. So, sir, I think participants from our participant sites, we don't have any queries. So, with this, we can conclude this session. So, thank you so much, sir, for sharing your knowledge and experience with us in this session. So, once again, thank you, sir. Thank you so much for sharing your knowledge and participating in this FDP. Thank you, sir.
Thank you, madam. Thank you for giving me some opportunity to share our research activity. Thank you.
It's, it's
So
our
shall I
pleasure,
leave,
sir.
madam?
Yeah, yeah, sure, no problem.
Our next session will start from 5 p.m. Participants, you please stay online. Our expert has already joined. Sir will start his presentation within few minutes. Our our expert sir has joined. Sir, may I audible, sir? Magesh sir.
Ma'am, actually, sharing the screen, I guess it has to be allowed, ma'am.
I think there is no type of permission sought from me. I think you can leave now and again join. Okay, sir. Now it is visible.
Yeah, I
Hello,
just
sir.
sharing my screen.
Uh-huh. Uh-huh. Okay, you please share your screen.
Good evening, everyone. On behalf of Electrical Engineering Department of Tripura Institute of Technology, I would like to extend my warm
Is the
welcome
screen is visible?
to the expert speaker of this session,
Is
Sir
this
Magesh Kumar, Senior Manager, Bharat Electricals Limited. Mr. Magesh Kumar has expertise in handling mega power projects of EPC nature. He was awarded for the best service towards the nation building in state-run Maharashtra PSC. He has specialization in quality and HSE system implementation in power plant construction. Today, we are privileged to hear from him about the topic coal to chemicals for Vikshit Bharat. Once again, I welcome you, sir. Sir, please start your session.
Yeah. Thank you, ma'am. Thanks for the opportunity. Back to back second session, I guess. I will make this session more interesting with respect to discussion. There are, I guess, 30 plus participants are over there. From, I guess, all are from electrical background. Is it right?
There is a mixed background. Some are from electrical, some civil and mechanical, electronics are also there. So
Okay.
it is a group of different branches are there.
Okay, then it is very good actually. Then the project seems to be more promising for the entire team, whoever is present over there. See, energy is a topic which is common to all the engineers. As soon as if you are inducted to our company, you will be called as an energy engineer rather than called by your team. Say whether you are a civil engineer or electrical engineer or mechanical engineer, all would be called as a power engineers as soon as they join in our company. Because everyone has an important role to play. They have to understand each and everything with respect to the product as a whole to deliver their requirement in a better way around. So the today's topic of discussion was energy sustainability. In that, a specific area had been I had taken today, that is coal to chemical. What is the contribution it provides in developing towards our developed India? How it contributes? Let us see. See, yesterday when I was discussing about energy sustainability and climatic change, I were discussing like coal was a major contributor with respect to emission. That was I was repeatedly in my presentation also I shared. And presently it is contributing energy around 60 to 70%, where emission it contributes around 75%. So it was strongly felt throughout the world, the abatement of coal sector is important to have greenhouse emissions in control. So here, how the primary energy we are getting in India, it had been listed over here. If you see, the coal is contributing around 55% of the energy demand. Crude oil is 29%, natural gas 6% respectively, which was notified here. In this, whatever energy demand that coal had been provided, 80% of the coal it is mined in India, and 20% of the coal is imported. And again, with respect to coal nature, the quality of coal, if you take, if you recollect, in our engineering, we would have studied coal of bituminous coal is, I guess, based on the calorific value, it had been numbered as G series numbers, G11, G12, G13, like that. Ours is grade of coal is slightly lower calorific value when compared with the imported coals. It's a bituminous coal, and mostly the coal is 75%. Indian coal is having 75% of the coal is of high ash coal is present in India. And the other thing, what I yesterday class also I was saying, like crude oil, only 20% is scattered by domestic rigging. Rest 80% had been imported and utilized. So if you see, with respect to energy, it is more than 7 lakh crore of our Indian money is being provided towards energy imports alone in terms of crude oil, coal, and other aspects. So to make a developed country, what is required is best utilization of the energy availability within India, either in forms of renewable energy, as well as if you are switching over from coal-based thermal power plants to other abating coal by reducing the emissions, then it is strongly felt a gasification route is the best way, which reduce the dependency of imports of natural gas and crude oil. So what is gasification? How it is being done? What is the role of BHL in it? What are the developments that have been done by a company over the years? How it is going to bring what is so-called developed India, how it could able to contribute. Those aspects we will see in today's presentation. So the topic for the day is coal to chemicals to attain energy sustainability. So in today's content, I will cover gasification fundamentals, gasification scenario in India, choice of gasification technology based on the coal availability in India, what is IGCC thermal power plant that I will touch upon, then our company BHL gasification journey so far, how far we have traveled, that I will show you today. Then application of gasification, what are the things it could able to contribute, what is coal to chemical, how methanol is produced from the coal, how urea and ammonia is produced from coal, how hydrogen and SNG, as well as how for DRI coal gasification aids, what was the progress made, and I will try to summarize in today's 1.5 hour session. See, here participants are free to ask any questions in between if they want to ask. It is not a thing, it would be disturbance. More than that, it will add value to the today's session as a whole. Gasification fundamentals. See how all the engineering fields are involved in a particular sector. The thing is that to building a power project or any gasification, any project as a whole, it requires like a mechanical engineer supposed to manufacture all the components as well as he has to assemble all sort of controls. It would be done by C&I, and all sort of electrical things it would be done by electrical engineering as a whole. And civil engineering, they will be doing based on the total project weight and corresponding design, what would be the civil foundation and what would be the requirements of the total landscaping, everything would be done by the civil engineering. Here in gasification, see, gasification is nothing but coal. Coal is rich in carbon material. It would be little bit chemistry in it. Be patient to hear to this. So coal is rich in carbonous material. Here on this one with a less oxygen, if you are doing combustion process, then it will produce carbon monoxide and hydrogen. This carbon monoxide plus hydrogen is termed as syngas, and it can be used for plenty of applications that we will discuss later down the slide. How it is being done? It is done within the chamber where high temperature, a amount of steam, oxygen and air is passed inside the chamber to produce carbon monoxide and hydrogen from coal. So what is combustion? What is gasification? Combustion is nothing but it is similar to the gas stove, how you burn your LPG gas and you combust it and you heat the water in it. That is combustion process. In the normal thermal power plants, if you say, the coal would be taken, excess air it would be provided in such that it would be completely burned in presence of heat, where it is completely combusted to produce exothermic reaction, and that energy it would be utilized to heat the water, and in turn the heated steam it would be used to run the turbine to produce the power. This is what in a thermal power plant ideally happens. In this process, whatever I had said so far, after combustion, whatever the flue gas it comes, after combustion, the hot air, it will have the combustible gases, like it will have numerous gases like CO2, SO2, SO3, NOx, everything, and it would be filtered and further it would be released to the environment. In this process, if you see the purification of fuel, whatever flue gases are there, it doesn't happen to that extent what is required to the in the environment point of view. But as in case of gasification, it can be filtered in multiple layers such that it can be made to a different product based on the purification process how it is handled. It would be more cleaner when compared with the thermal power plant. If you do gasification, we could able to filter the things and we can convert to various products. Only thing we have to find the economical way of doing it. Here, instead of excess of air inside the combustion chamber, excess of fuel is used, where instead of more oxygen oxidizing atmosphere, here the oxygen content would be reduced so that it doesn't burn completely. Here lot of energy would be absorbed, in the sense a part of the fuel would be burnt to have exothermic energy. Part of the thing that whatever heat is there, it would be absorbed for the chemical process. So here the process inside the gasification is endothermic. Exothermic is energy it would be released, endothermic would be energy absorbed. So the carbon, whatever excess carbon in the fuel it is there, it would be converted to carbon monoxide. Sulfur it is converted to hydrogen sulfide, and carbonous sulfide. Nitrogen is converted to ammonia. So what are the basic chemical reactions over in the gasification? It would be, first the coal would be dried in the temperature of 100 to 200 degrees Celsius. Further it would be done pyrolysis. Pyrolysis is the process where in a range of 600 to 100 degrees Celsius, 600 to 1000 degrees Celsius, in a less oxygen environment, the carbonous material it would be heated so that the coal becomes like a char. After the char, it would be further gasified in the equivalence ratio, that is the oxygen ratio in the ratio of 0.25. 0.25 times of carbon, oxygen would be supplied, and it would be gasified. Gasified in the sense the carbon along with steam, it would be converted to carbon monoxide plus hydrogen. Here this process, it would be like absorbing 131.3 kilojoules moles of energy for this reaction. And again a shift reaction, carbon monoxide it would be further releases heat, it combines with steam to form carbon dioxide plus hydrogen. This is a shift reaction. Then followed by hydrogasification reaction, carbon plus hydrogen steam, the hydrogen which is produced from the steam used to prepare methane, where again is energy absorbing reaction. Further, carbon plus carbon dioxide joins 2 times of carbon monoxide. Here it would be liberated. See, the thing is that all these things happen within the chamber, where the product, intended product would be carbon monoxide plus hydrogen, which is called syngas. Here the reaction would be irreversible and reversible reactions. Practically all these reactions inside the gas chamber was irreversible. So where the syngas, what we are talking about, where it can be used. See, once the thermal power plants are no more, the coal can be converted to syngas. Further, it had been used in different products and different industries. Those applications are listed here. Either it can be used in the iron reduction, in the process of preparing iron ore to the raw material what is required in the preparation for the iron reduction process. This syngas would be used To produce clean electricity, syngas can be utilized. For the transportation and aviation fuels, it find the usage, as well as building blocks of chemicals and fertilizer in the medicine industry, as well as fuel gas and SNG, it can be utilized. So the gasification scenario in India. See, are we talking about some technology which is not there in the entire world? Definitely no. There are around 272 plants in operation, planned with a total 686 gasifiers around the world. So what is so significant with respect to India's energy dichotomy? So here, energy transition, yesterday also I was talking about, where we are converting our total energy generation to a technology where it emits lesser impact to the environment to make it more sustainable for living. So diversification of coal from the thermal power plant towards these kind of industries are picking up. Right now, India's coal gasification mission 2030 mission document had been prepared, where it had been targeted to convert 100 million metric tons of coal to get gasified to coal to chemical as different products. So in this target, what it provides is like it helps to meet the international targets of COP26 to phase down unabated coal power. Unabated means where the carbon dioxide is not captured. That import dependency of energy security, like we could able to reduce our import by 7 lakh crore, which is presently we are procuring from outside for our energy demands, which I notified in the earlier slides too. Then what is the growth of this sector is it's around 2.4 CAGR, compounded annual growth rate. Why we have to think of these technologies? In what way it contributes to the energy sustainability? The thing is that India is the 5th largest producer of coal, which I had shared yesterday too. We were having the production of around 716 metric ton presently, which is being utilized for various applications. In this, we were targeting to produce further 100 metric tons of coal for this particular purpose to cater the demand of what it had been showed in the import dependency part. We could able to, instead of importing 226 million metric ton of energy, we could able to gasify 100 metric ton as a commercial scale is in plan to produce, gasify those things to such that we could be able to reduce the import bill by half. Where if you could able to reduce the import bill by half, those money we could able to spend for development activities for our country. And with respect to the estimation reserves, presently how much coal is there? When we are talking about abundant, how much is the quantity that need to be quantified? That quantity is around 352 billion tons of coal, and lignite is 46 billion tons. What are the places we are having coal? It is around 120 of 700 districts in India. It's directly dependent on coal. What it offers to the local people is like nearly 1 million indirect jobs and 3 lakh direct jobs is offered in Jharkhand alone in the coal sector presently. So what was the target of the ministry? What I notified, it was mentioned over here. There are 3-phase program by the government of India. Phase 1 and phase 2, it is 10 million metric ton, and phase 3 by 90 million metric ton. Presently, technology and pilot scale, it had been done in many companies. Commercial scale is in progress. What Niti Aayog offers is thrust on methanol-based economy. The thing is that methanol would be produced from the coal gasification. That would be blended with our normal crude oil fuel, and it would be used. In the way, we could able to reduce our import bill, as well as we can reduce the CO2 emission by capturing techniques during the process. So for this, what are the things that have been done in the company? It had been shown like one Apex committee member, national level committee member, BHL CMD was one of the member. As well as in Tiruchi, there is a standing committee for the coal gasification had been made, and they have been continuously working on it. So what are the incentives presently provided? Presently, the technology is developed. It is like in the commercial implementation phase. So BHL, we the company having a pressurized fluidized bed gasification technology, which is indigenously developed, and it is going to commercial by having a joint venture with Coal India. For this, government is giving waiver for GST compensation for 400 ton for the entire gasification. So BHL likely to play a pivotal role in achieving the objective of National Coal Gasification Mission as a Atmanirbhar Bharat initiative. So here the investment, what is the investment required for this particular project to come up? So in order to gasify 100 million metric tons of coal, what is required is almost, it is like for every 1 million ton, it requires approximately 5,000 crores. Here it was a conservative figure. If you take the real investment, it goes up to 10,000 crores per million ton of coal gasification. So it is a cost expensive technology presently, which requires a lot of engineering in it, lot of research over it to reduce the cost of equipments manufacturing, as well as technological improvement to reduce the cost so that we could able to gasify things and able to deliver better way around for the Atmanirbhar Bharat. So what are the primary drivers for coal gasification in India? So as I already told, we are having abundant proven reserves for 140 years based on the reserves available and the rate at which we are mining and utilizing for various purposes. So what are the products we could able to gasify from coal to chemicals, where we can generate hydrogen in it, which is called as gray hydrogen. Actually, we discuss about green hydrogen. Here, if CO2 is not captured, it is called gray hydrogen. Then methanol can be produced, dimethyl ether can be produced, olefins, acetic acid, formaldehyde, and ammonia. Presently, if you take in these chemicals, we are importing again. There also a huge money is getting invested by Indian government to import these chemicals for various usage in our industries. If we are converting coal to chemicals, then we could able to reduce the import and we become self-sufficient in meeting those demands. Then import substitution of fuels. As we discussed yesterday too, hydrogen was if you are producing hydrogen, then you could able to reduce the emission to a greater extent where it is being burned. If during the generation, if you could able to filter all the pollutants, then you will be producing a sustainable way of using the fuel in better way around, which is eco-friendly. So presently methanol, which can be produced from the coal gasification, can be blended with gasoline M15. Dimethyl ether can be blended with LPG, 20% blend can be done. See, whenever you are doing blending with various compositions, you are reducing the import to a greater extent. In that way, we could able to reduce the import dependency to an extent. We can reduce the bill paid towards our imports. So what it offers to the sustainability, it is like the sulfur during the process is completely removed, and the sulfur compound can be drawn out of the gasification process as a product, and it can be used in other chemical industries. Here NOx formation can be this one again. This can be a filtered NOx should be available, and it can be converted to different products based on the requirement. Even carbon dioxide, the purest form of carbon dioxide, it would be comes as a byproduct. It can be stored or it can be converted to useful product based on the availability of various technologies, which is under development. So far I was discussing about the chemistry part, then some of the aspects of it can reduce this thing, the many superficial things we were discussing. So far what had happened in India. So the total gasification experience in India, it had been highlighted in this slide. So right from 1940, from the wood gasification till in 2022, NLC Neyveli Entrain Bed. These are the various projects some are in operation, some are in different phases. It had been highlighted here. The key things which I like to say was with respect to BHL things. First, let me explain. In 1985-92, as a part of experimentation for our own plant at Tiruchi to generate power of 6.2 megawatt, we put 150 TPD tons per day coal gasification unit in Tiruchi. After putting the plant, based on the operation experiences, what we found is it had lot of operational issues based on the based on Indian coal nature. Then what we done is around 92, it was under operation for 7 years. After that, by in 1992, what it has happened is it had been modified with our indigenous developed technology like pressurized fluidized bed. And for this, more than 50 plus patents have been filed. So this plant seems to be more proven in the operation to generate power, and it had ran more than 10,000 hours of operation. So the technology which had been proven, that design had been vetted by national level R&D committee, as well as the design is ready for 125 to 182 megawatt capacity pressurized single fluidized bed gasifier were made ready for operation way back 1992 and till it is available. Then what went wrong? Why this technology not come to the limelight? Even if it is more sustainable, why it is not in place? If you want to know, the thing is that economically, when compared with the commercial combustion boilers, it is relatively costly with respect to the operation. Based on the economics, yesterday I was saying the power cost, if you see per kilowatt, is hovering around 6 rupees. More than 6 rupees, it would be too tough for the end customer to pay, as well as it would be difficult for the end buyer to install those equipment and operate those power plants. Hence, it is believed like IGCC power plant, it would be not competitive when compared with pairs of combustion power plants. So then the technology was there and it had not been utilized that much. In 2000, again, it had been our neighboring country, China, they done a lot of gasification projects where they were blending methanol to a great extent, and they are doing double the times of gasification what we planned. Already they were doing. So after sensing those things and studying the external environment, a plan had been proposed to have pilot projects in place. So our DST had funded for a technology which had been developed in our corporate R&D for 0.25 tons per day methanol synthesis plant, which was commissioned in 2021, where we could able to produce 99.95% pure methanol in our pilot setup. Similarly, by JSPL Jindal Steel in the Angur plant, they put a fixed bed, Largi air liquid. Actually, here what they are using is like a washed coal, in the sense they are reducing the ash content. The coal is washed and it is converted to syngas, which is being used for DRI application. That is for in the steel reduction process, they have been using this, and it is in operation even now. In between, it had been stopped for a while and it had been put in operation. So these are the other projects like RIL Jamnagar. It is in operation since 2018. Actually, this fixed bed, by changing the coal, they are using this. When I was saying about BHA technology for the own, actually without doing any washing process, we were using directly the coal. And for the directly using the coal, we have developed the technology, how to use it has been developed. As in case of this, the proven commercial different design had been taken. And in that, they are washing the coal and they are using for the operation. With respect to Jamnagar, it is again end-to-end bed is another. Totally, there are 3 technologies that I will discuss in later slides that will get to know. This is with respect to RIL Jamnagar Petcoke gasification plant. What is the technology? What is the licensor? Who is the contractor? That has been mentioned over here. Then choice of a gasification technology. See, actually, yeah,
Sir, one of the participant has raised hand. I think
yeah. Please, please.
Dr. Rashmi Sharma, I think.
Yeah, yes, sir. Yes, please.
Okay, sir. I think she will ask question later on. So you please.
Okay. See, it is like one suit doesn't suit for all. So whatever technology is developed, everything we can't borrow and develop, borrow and use here. With respect to the coal, what it was here, the reactivity of our coal is moderately high, but our ash content is 35 to 45%. As in case of foreign coal, it is less than around, if you take, it would be less than 25%. So based on this is the major criteria which differentiate our coal and as well as the usage of technology. Presently, the coal gasification technology with respect to fluidized bed boiler for Indian coal condition, no technology has been commercially proven till yet for this high amount of ash, except which is had been developed in house. So we have been going for the commercial operation shortly. What are the challenges? Challenges I had already shown. It is a non-coking coal where high ash is there, low rank, weather deactivated coal. Major variation in quality of feedstock. In a single mine, we are getting various variation of coal quality and large quantity of coal fines in feedstock, slurry-based technologies. So environmental related. So today, whenever we are developing any technology, we have to think of this environmental aspect, without which either the technology nor the buying of the technology it would be there. So a large quantity of waste, black water generation, if you are using the other technologies are there. A costly water treatment plants were required when you are using the other technologies, which is not there for the technology which has been developed by BHL. Then technological related, what are the other things was, as it was notified earlier, it is proven for low rank coal. The coal field preparation very critical and complex with respect to other. That is not the case with respect to the pressurized fluidized bed gasifiers. So this is technical parameters how to operate to generate syngas. See the inside the gasification chamber. If you want to compare it, if you want to compare with respect to the way how it is like in a pan you are cooking some curry in a different layers. You could be able to prepare differently if you add more water to it. Whether it is rasam or sambar or dal, how you filter it may change. It's a crude way of explanation. But the thing is that inside the gasifier, based on the amount of steam, amount of oxygen you are putting into it, by varying the proportions, synthesis of various chemicals, we can draw it from the same gasifier. So these are the three different technologies with respect to gasifier. So the middle one was BHL preferred one for the Indian coal conditions, where it would be the ash can be removed similar to the normal thermal power plant. Effluents are none. When compared with the other two, there is a lot of wastewater here, a lot of tar and phenols would be there. Here effluents would be none other than ash. Even the ash, it can be used for multiple sustainable ways of converting to different compounds are available. Here also a lot of commercial aspects can be done actually. It can be used in cement industry, it can be used in the brick kilns. 100% utilization of ash, it's need of the day. So directly you crush the coal and you can feed it inside the gasifier and you can gasify and convert to different chemicals. That is the technology which was developed. As in case of other things, it has to, in this case also it is almost similar size, it can be used, but the temperature at which it is being operated is slightly lower. Here it would be ash and dry process of removing. As I said, the tar and phenols, it would be very difficult for the Indian coal to remove. We face a lot of problems in this. With respect to entrant bed, we have to wash the coal so that ash content should be less. See, ash is one thing that doesn't involve in any gasification process. whatever is there, it is just like it comes out after the process. It comes out. It is totally. It is like a waste in the entire process until otherwise we find usage of it. So for the ash content less than 25%, they can go for entrant bed. See, here going for the different technologies. The thing is that inside the fluidized bed gasifier, also you can use all sort of all type of coals. But the thing is that this particular process, it was commercially proven, and in this they find it operation friendly. In case of if it is less amount of ash is within it. Then gasifier technology and the present choices. So what the technology we had used, what is available with BHL, it had been highlighted. We are having both fixed bed as well as fluidized bed presently. And others are like the other companies, designs also mentioned here. Who is having what? It had been mentioned over in this figure. These are various designs of gasifier technology available. In all the gasification process, the thing is that coal would be fed from the top, then ash would be removed from the bottom, and further water and air, it would be added. Water in the sense of by hot steam, it would be added in the process. First, the coal would be put inside the chamber. Any gasification technology, inside the chamber, coal would be put. A quantity of coal, it would be burnt. In that heat, further coal had been added. Then further steam would be given. Then sufficient in the sense less amount of oxygen would be given for the chemical reaction. Here they will do both energy balance as well as mass balance. In equilibrium condition, if you see whatever equations we discussed earlier, it would be gasified. The gasified gas would be taken and it would be further filtered, and it would be converted to different compounds in down the line by various processes. The same thing happens in different technology in different way inside the gasifier. So these are the gasifiers, how it is being operated. There, this is called cyclone separator and other things. This is what I was saying, like a fluidized bed gasifier for Indian coals. It find the maximum usage, where the coal would be fed this way around. Air and oxygen, it would be sent this way, and ash, it would be removed like this. Whatever syngas generated, it would be taken to actually under 30 bar pressure and around 950 degrees Celsius, the gasifier would be operated. The entire chamber, including circulation separator, everywhere the 30 bar pressure would be kept, under which the entire process happens. The gasified syngas would be taken for further filtering and converting to different products. So integrated gasification combined cycle. See, you would have seen gas turbines and red gas turbine too. Similar to that, after gasification, whatever syngas comes, if it is burned and further it runs the gas turbine, it is integrated gasification combined cycle power plant. The major difference between the steam thermal power plant and the integrated gasification combined cycle, their complete combustion happens inside the boiler here, where steam would be used to run the turbine. As in case of gasification, a syngas would be produced, the particle matters, everything would be removed. Then the syngas, it would be sent to gas turbine. After combustion of the syngas, the hot gas, it would be sent inside the gas turbine to run the gas turbine. In turn, will generate the power. So this presently in Indian condition, if you see, the cost of integrated gasification combined cycle is more than affordability. So these are various IGCC plant which have been available across the globe. Various capacities of IGCC plants, demonstration plants across the globe which were there. It had been mentioned here. The design aspects of various IGCC power plants had been shown here. The pressure of various gasifiers had been shown, the of the plant, the turbine, different types of turbine nomenclature had been given. Then technology, it had been notified here. With respect to design aspects, so the gasifier can be a single cylinder, what I shown in the picture, or it can be a two-stage flow, two-phase, based on the type of flow, it had been mentioned here. and how the coal is fed, and what is the blending. Based on that, it may differ, as well as oxidant, how much oxygen or air directly we are sending. Based on that, also the gas phase are getting changed. These are all our operational aspects. It would be helpful if you are learning these things for the operation perspective. And funding, actually, there also they done as a demonstration plans only. They have been built across the globe to find the viability of converting those things and generating power. But everywhere it is like when compared with the pressurized thermal power plants, here it is relatively costly to generate the power by these processes. So now it comes to BHL gasification technology. Any doubts are there so far with respect to technology before going to BHL point of view? Anything you want to ask? If no, I will proceed. Okay. I guess.
Hello, sir.
Yes, ma'am.
Acha, what is the specialty of Indian coal in comparison to US coal? Is it good, or why the normally coal is exported from outside, as our coal is also quality?
Actually, two things only, ma'am. For any mine to this one to excavate a mine, a new mine, if you want to mine coal from Indian conditions, it took more than 5 years, and big capital equipments are required to mine the coal. That is one part. And second thing, with respect to Indian coal, as I say, 75% of the coal which is available, it is having less calorific value. In the sense, the calorific value of our coal would be around 5,400 kilo joule per kg. And if you see the imported coals, it would be more than 6,000, and it 6,200 around kilojoule it would be there. And apart from that, the ash content of our coal was relatively high. Say, for example, if you purchase 1 ton coal, if I say the ash is 25%, in 1 ton, only 750 kgs it is of carbon, which will give you energy, and the rest 25% it is ash. Ash, that is a waste you have to handle further. So that would be the handling of ash. People find very difficult. When it was imported coal, the ash content is less, so the amount of ash generated from burning the coal, it would be lesser. And second thing, even by mining the full capacity all the times, even though it was we are continuously investing and mining it, based on the growing demand of coal, we could able to mine only 80% of the requirement we could able to meet by our mining. To meet the 20% further requirement based on the that much power plants are available, we are purchasing further from the imported coal. What we do is like we will blend both. Imported coal, it would be mixed with Indian coal, and it would be used in our power plants.
In the blended form, it is used in the power.
Blended form, it would be used in power plants. And further, some of the processes, based on the technology, what I notified, like entrant bed and like for example, steel reduction, Tata Steel or any steel company, if you take, in the reduction process, in the reduction of mineral ore to iron billets, there also actually syngas and other things are required. If they are taking the imported coal, again the ash content would be less, then they can use entrant bed gasifiers. They can use it effectively in those technologies where at lesser cost they could be able to produce steel presently. One is development of technology for using Indian coal. The other is based on the mining capability of our nation. We are importing coal.
Okay, sir. You continue, sir.
Yeah.
Thank you.
Yes, ma'am. Thank you, ma'am. Now it's a BHL gasification journey. So it started way back 83. It is almost older than me with respect to the gasification development program. If you see, way back 83, it had started the first gasification project, And in 92, it had built a 9.2 megawatt moving gate gasification demonstration plant at Trichy. It was successfully operating, but then during operation, a lot of issues had been faced. Based on the issues in 96, it had been retrofitted with pressurized fluidized bed gasifier. Even today, it is there at Trichy. If anybody come to BHL Trichy plant, make a visit. It was visited by almost the top technocrats of the nation. Then in 2000, pressurized fluidized bed gasifier process had been established. In 2003, in the process, the major subsystem modification. Actually, if you see from 96 till almost, it is like if you come around till 21, there is numerous, more than 50 plus patents have been filed in this technological developments to produce the methanol as a product and other gasification process to the standard what is required. So for this, big team is continuously working on it, and lot of this one simulation softwares have been got, and we were doing a lot of simulation studies to the extent what is required. Today, we are this one commercially signed a MOU with CAL, Coal India Limited, for 2000 tons per day ammonium nitrate. It would be produced by the gasification of 1 million tons of coal. It would be gasified to generate 2000 TPD of ammonium nitrate. And again, with NLC type in process to build IGCC plant as a demonstration plant, they are trying that has to be that is in process. We have to see what it happens. Still, it is not come to fruitful. So, with respect to the cost of 150 TPD, which had been installed way back in 82, what was the cost? It had been mentioned here. During 83, it was around 15 crores. They had built this project. It was inaugurated by the president of that time, Sir Venkatraman sir. The plant had been put into operation. You can see the that time the amount of importance which was given, and this was Asia's first coal-based combined cycle plant, which was built and successfully operated. Later on, further modified, and it had been utilized continuously. Now the project site is still available for people can see over there. So this is a schematic sketch of 6.2 megawatt IGCC moving bed gasifier. So for the C&I electrical people, what is so interesting aspect is like whatever equipments you are seeing everywhere, the entire brain of these equipments have been controlled by them only. All the instrumentations for whatever temperature parameters, temperature, pressure parameters, everywhere there would be controls, and it would be connected to the Max DNA, and through Max DNA, the control systems, they would be controlling the systems in remotely. Electrical and C&I plays a major role with respect to the complete integration of entire systems in place, where mechanical would be manufacturing these things and assembling things at place. So then a summary of moving bed gasifier operation of our plant, how much time it had operated, and what was the efficiency, other aspects have been shown over here. Then gains and limitations of moving bed gasifier. So if you see, the gains were design experience we got by building this. Then operation issues had been found. Then what are the limitations of it we could able to sense by building this. The process, it had been found not amenable. We have switched it to fluidized bed gasifier based on the operation issues. So this was a real peak of the plant. This is being built at Trichy. This is moving bed gasifier. This was a methanol demonstration plant which had been built at Hyderabad. And this moving bed at Trichy had been converted to CCDP plant, in the sense fluidized bed gasifier had been put. Then this fluidized gasifier output had been used for running the gas turbine, which in turn produced the power. In PDA Hyderabad, they put the methanol conversion plant further, and they had produce coal to methanol, and the first indigenous methanol plant had been demonstrated to the nation. So this is the control room. Way back, our engineers in operation. That pic had been shown here. This is our IGCC demo plant which had been built in Tirchi. This was a glimpse of 6.2 megawatt pressurized fluidized bed gasifier. Again, IGCC demonstration plant which had been built in Tirchi. This is a circuit which we usually see in drawing in books. Many of us would have been read. It is a gasifier. This is ash handling system, and this would be coal feeding cyclone separators, coal feeding cyclone separators, and other things. Once syngas is produced, there would be 3 cyclone separators. Further, it would be taken. Everything would be the particles. Basically, it would be filtered here, and it would be recirculated empty number of times based on the efficiency of the gasifier. Once it is completely converted, it would be sent to heat exchanger to reduce the temperature of the syngas. Then after that, it would be sent to various purification unit based on the requirement. What is the end product? It would be converted and it would be utilized. So this is a fly ash recycle system with an open seal. Okay. So for whoever had seen, not seen, see gasification, whether it would be done only for coal, definitely not. We can gasify rice husk, we can gasify rice straw, we can gasify mustard crop residue, we can gasify lignite, even we can gasify this one biodegradable waste. So gasification, it can be done in anything. Based on the source of raw material, the technology for gasification, it would be changing. After gasification, everywhere you will have this one syngas or methane as a product, end product, and further the circuits are the same. Based on the usage, you can use it. So all these things have been tested in our gasifier at feedstock. So what is achieved by BHL was they had operated for more than 12,500 hours, and they gasified more than 50,000 metric tons for the demonstration purpose. And more than 105 gasification test runs have been conducted to optimize the operating parameters. See, many of you have been just when I connected the artificial intelligence session was going on. So see, by applying AI in these, see those days gasification test runs had been done before the advent of say artificial intelligence. But when you implement those things, we can even this operation parameters, it can be optimized in a better way around by implementing those technologies that people can thought of actually. There are a lot of research is going on in those aspects, how we can simulate the things in a better way around and optimize the results. So more than 4 lakh units have been generated by the gasification plant, and it had been supplied. Then its a conceptual design had been built. Further, the committee had whatever design is that there was a proposal to build the plant. Then finally, based on economical aspect, the projects have been called off. So this is the journey of BHL timeline of gasifier development. So today we could able to do 2280 TPD in a single line gasifier. Like a single gasifier we can use to produce that much. Even oxy blown conversion in Hyderabad unit, they developed a gasification technology to produce 0.5 tons per day methanol production. So people who are not seen thermal power plant, here is again a pictorial view. This is our thermal power plant, how it looks like. This is called as boiler. This is the first pass they call, this is called a second pass. Here inside, this actually coal would be fed in 4 directions. It would be burned inside. Then on burning it, the flue gas would be passed through this. Then it will be passed through the ducts. Then it will go to electrostatic precipitator this side. Then it will be filtered. Then it goes to the chimney. This is only a boiler had been shown. There the superheater coils and other things are there. The entire inside the boiler, inside the tube, water would be flowing. It would be heated and it would be converted to steam. The steam would be further heated to superheated condition in the red color region, what it had been shown as a superheated coils. Further through the ether and pipes, it would be taken to the turbine to roll the steam turbine to produce power. That is with respect to thermal power plant. But as in case of circular fluidized bed gasifier boilers, here it would be gasified, and the gasification gas, it would be again here also this one, the gasified, it would be heated to produce steam, and it would be used in the boiler. As in case of IGCC, the syngas, it would be burnt, and the burnt syngas, hot gas, would be run the gas turbine, and they will produce power. So based on the usage, the choice of technology comes with the techno-economical conditions. That is as well as technology, as well as based on the coal parameters, as well as the economical point of view, a particular technology would be selected for the operation. So here the normal flow chart of an integrated environmental system. The conventional boiler would be there. Then it is like removing the ash, the various process, how it is being done. See, the sustainability, everything is getting added. The way it is filtered, and it is not having any impact to the environment. Everybody require energy. How it is produced, how it is getting utilized without harming the environment is a key for the sustainable living. So by implementing various products in between, it could able to filter to an extent. Today, technology is available where we can have zero effluent power plants too. But the thing is that economically it should be viable, and to an extent such that people could able to afford to use those technology. There plenty of people can apply their mind to develop those things. In commercially available technologies are need of the hour. So this is way back in 2017, Niti Aayog person had visited our Tirchi plant for how our gasifier works had been seen. See, the coal, it would be gasified to syngas. The syngas can be directly transported for using transportation, or hydrogen can be used for various industrial application, or it can be used directly in the IGCC plant, or it can be used for ammonia production. The ammonia production, it can be further converted to ammonium nitrate for explosives and fertilizers. It can be used. Here again, ammonia also, lot of ammonia had been imported. If this ammonia had been given to fertilizer industry, they will prepare urea out of it. Further, the syngas can be converted to methanol, which can be blended with petroleum products for transportation purpose, as well as in iron ore reduction. They can supply this for the steel industry. They can utilize it. So these are the and the methanol, further it can be converted to further chemicals. These have been getting utilized in a lot of chemical industries, as well as in the pharmaceutical industries. We find application. So various air blown. So what is the proportion of air is blown with respect to the various gas production? See, based on what is the end product required, we have to alter the input parameters. Based on that, the ratio would be altered, which is notified here. This is how coal to chemical in short. If you don't want to know the entire detailing, simple is like coal. It would be taken from the mine. It would be stacked in a coal yard. Then by handling system, it would be taken to the gasifier. It would be fed inside the gasifier. Then in the gasification process from air, as I say, only three things. One is steam, the other is air, third is coal. All the three things would be put inside the gasification unit. After burning it, the gasification starts. A part of the coal inside the gasifier, it would be burned. Gasify. Once the gasification done, the syngas would be sent to the syngas cleaning system. Rest whatever after burning ash, whatever is being produced inside the gasifier, it would be removed by the ash removal system. Once the syngas is produced, it would be conditioned. Gas would be cooled, and further synthesis and purification done to convert to various products. So the process flow of the entire thing in detail, it was shown here. If people are interested, they can go through this. It is the same detailed way it is being given. Again, the process flow of different islands. See, here why we are saying island 1, island 2 is like, see, each process is a particular technology. A lot of technological things are there. As we say, it's like a single word, it looks, but it's like each one forms a, we can assume it is almost like 3,000 crore worth the project. This gasifier is 3,000 crores. Then island 2 for all this purification unit, it would be 3,000 to 4,000 crores. So similar to that, each island package, it's have numerous systems, numerous control systems, numerous technologies in place. Many modules are there in place to do these processes. How each chemical reaction, say the purification process, for removing the hydrogen sulfur content from it, and removing the traces of nitrogen in it, all this process involves huge purification process. Here also technology, a lot of technology like by MOU, it is being obtained, as well as in-house technologies are getting developed in-house. Here also a lot of research is underway and it's going on. So based on the temperature and operation pressure and what would be the catalyst for the process had been mentioned, and what would be the nature of reaction is mentioned over here. You can go through. Then various contaminants. See, by the process, what are the contaminants, at what ratio it comes? By any process, what would be the percentage of effluents coming out from the process? Based on how much effluent it comes, the filtering systems has to be effective so that it is eco-friendly. It is being built accordingly. So methanol, it's mentioned here. Gasification of various feedstock. See how much gasification. So primary feedstock, how much is planned, how much is in construction, how much is in operating. This is a worldwide figure if you see DOE. And similarly, gasification by application. For coal, they are gasifying a lot of things. And in this, what they are converting more was chemical. They are converting max presently. And then the second is gaseous fuel, then liquid fuel and power. Power is the least being used after gasification. Based on 2010 survey, this was being given. How much gasification is done, what process it had been used worldwide, it had been shown here. So why methanol? So methanol, why methanol need to be gasified? Many products are there. Why methanol? Here presently 15% methanol blending is being done at China. Say if you are blending 15% in our fuel, we can reduce our import by 15%. That is the key. China is the second largest coal reserve. 70% methanol through gasification is produced by them. Rest they are procuring from outside. Global and at times like it is like whatever they produce 70%. At times they are catering almost 55% of global methanol production they are doing there. They at times they are supplying to. They are having more than 100 plus gasification plants. They are way ahead than us with respect to having gasification plants. And there they are blending 15% methanol with 85% gasoline. So these are what is being done. 35% of the methanol through gasification worldwide they are producing. 25% of ammonia produced globally through coal gasification route presently across the globe. So this is China blending. This is a methanol feedstock market. What is the market availability? See, two things with respect to products and technology. If you see as engineers, two things. One is developing a technology. End of the day, developing a technology need to meet the commercial aspect, the need, requirement, the pain point of the society it has to meet. So methanol, whether it is a requirement, yes, it is a requirement. It has to replace the fossil fuel. We are having less crude fuel residues. If you want to reduce the amount of import, then we have necessarily produce methanol and we have to blend with fossil fuel for our energy independency. Then a global projection with respect to methanol requirement and how much it would be there. See, globally it is being sensed like the business is around $17.94 billion of business with respect to methanol market, and CAGR, the growth rate is 4.6% was predicted. The global market was continuously this one. It is growing with respect to the methanol requirement as well as usage. So methanol economy as well as others. So this I had explained what is the infrastructure required with respect to this, as well as this one. By producing this, what are the benefits of it? That ethanol can be produced from the food crops and grains. Methanol can be produced from the coal gasification process. Okay, methanol as well as practical alternate fuel, where it forms the gravity density, volumetric density, where it lies, that has been mentioned here. The volumetric energy density is 1.4 times of hydrogen. Okay, and then these are the snippets with respect to methanol. What Indian government thinks for, where Coal India floats tender for $813 million for coal to methanol plant in West Bengal, and India to divert 100 million tons of coal to gasification plant. In turn, it is like reducing the environmental impact. This has been thought of, as well as energy independence towards a developed nation, that it was aimed for by investing in these projects. As well as air products. See, for the gasification projects, air is required, oxygen is required. Again, for this also technology need to be developed. Technologies are available across the globe, as well as in-house technologies are being prepared for this gasification project. As I discussed, once the methanol is produced in-house, it can be it would be cost lesser if you are producing in-house, and it can be blended with the coal. It can reduce the fuel cost, as well as it will reduce our import bill. So this is like various NLC had floated tender. Still, it is not capitalized. Actually, it is still in ordering stage. So it is a various targets of government of India had been mentioned over in this slide. So what would be the rate of methanol, ethanol, gasoline had been mentioned over here. The price data of 2021 by sources Niti Aayog report, methanol competitive alternate fuel. Presently, what would be the cost of producing? What would be the energy? What is the paid by price paid on the energy equivalent presently? What would be the proposed cost? Price paid to replace 1 liter of petrol on energy equivalent, it would be 37.62 plus tax. So it's like you'll be spending 37 rupees for replacing 1 liter of petrol with 1 liter of methanol. So it is almost if you compare with the 2021 rate, it is far cheaper. When we are blending, we can reduce the fuel cost. Whether it would be passed to on individual or customer, it would be reducing the import bill of government to a great extent. Then with respect to Niti Aayog methanol, a comparative alternate fuel, it is the cheapest alternate fuel available. Government is yet to define the tax structure on methanol. How it is going to be done, it is yet to be, the policy need to be rolled out. Presently, the commercial scale methanol projects are not available to the extent which is required. It is in the process of building those things. So building these various gasification projects, we could able to convert various products which finds application in various industries. It reduces the import, as I was repeatedly saying. Then with respect to natural gas based methanol synthesis, even natural gas can be used for methanol synthesis, and methanol can be produced by using that. These are the various reactions, chemical reactions, which I had mentioned. Here, the negative shows that the energy it would be released by the process. Plus, in the sense, energy would be absorbed. Negative in the sense, it's an exothermic process as such. Then, for the methanol production, how many moles? So this is by mass balance. How many moles is required for the process? It had been notified. So, what is the use of methanol production? Had been this one. Presently, the installed capacity is only 0.733 million tons. where the net consumption is more than 1.83 metric tons with respect to these industries. Domestic production is very less, net import is much higher. So it is like 90% of India's methanol requirement is made through imports. Then again, the various application of methanol is mentioned that I had already explained this. This is in abroad how it had been used for powering automobiles as well as ship. Then economy challenges with respect to environmental impact, where it stand with respect to energy density, only half of gasoline, 24% less than ethanol. Then what are the safety hazards? Methanol is toxic. If accidentally released from the underground storage tank, can rapidly travel through groundwater routes and contaminate well water. These are the safety hazards with respect to methanol. It is highly corrosive to metals like aluminum, zinc, manganese, would need modification of engine fuel in tank systems. It requires modification of systems before adoption of these technologies. So this was the demonstration plant which was demonstrated to our Niti Aayog Chancellor, distinguished scientist Padma Bhushan Dr. Vijay Kumar Saraswat, way back at 2021 at our premises. The proud moment for us. This is our pilot plant which has been built at Hyderabad. This is the schematic drawing. This is yeah, as I say, this is gasifier island where coal gasification happens. After that, if you see here, the ammonia removal and COS hydrolyzer. After ammonia removal, it will be sent to water gas shift reaction, and H2S it will be absorbed. Further, CO2 removal unit is there. After CO2 removal, it would be sent to methanol synthesis plant. A part of it here again it would be sent to H2S removal unit with respect to a part of it from this it would be sent. In the methanol synthesis group, after this it would be synthesis, and further the crude methanol it would be purified for usage. So this is our coal to methanol process, where gasification unit air would be fed, coal would be fed. Further steam, actually it was not mentioned here. Steam also it would be fed inside that. Then after gasification it would be filtered. After shift reaction it would be cleaned up. Sulfur would be removed. CO2 would be removed. After that by purge gas recycling methanol synthesis would be done. After that it would be distilled, purified, and it would be sent for usage. So what is government is offering here? There it built a task force expert committee in the coal ministry. There was a roadmap and plan had been developed, and it had been dictated who will do what, and they are classified what are the targets with respect to each this one. They prepare the roadmap from coal based H2 production, and for the hydrogen production, coal was important source as such. By various processes it is getting produced that had been notified. Then coal to syngas. Presently, if you see again, it is like how much imports are there, how much it is being utilized, what is import bill, it had been notified here. Then direct reduction of iron. This is a metallurgy purely. In the metallurgical process, syngas is required. The syngas can be produced from the coal gasification, and it can be utilized in this process. Again, by doing this process, you will be reducing loss of a lot of import, as well as the CO2 emissions. It can be reduced by implementing an in-house process, as well as capturing those things. Yeah, in this process, natural gas would be imported. If natural gas had been replaced with the syngas, again using of this an importing natural gas, it would be reduced for this DRI process. It will save a lot of imported natural gas as well as imported coal, provided if you use indigenous coal for these operations, and our technology can be implemented for this for usage. Then process industries, these are purely metallurgical things. That is, iron oxide can be converted in two ways. That is blast furnace and direct reduced iron by various processes. It had been mentioned here. So these are chemical reaction with respect to DRI process. See, gasification, as I say, it is same. A gasifier would be the coal, ASU, and steam. It would be provided for gasification for the gas cleaning condition, and it would be used for DRI process. So again, urea and ammonia. So what is the market space? With respect to market space, these are the industries which required this one chemicals with respect to Indian fertilizer sector. Again, presently this one this is ABAP process where natural gas is converted by gasification and it is being utilized. Instead of that, even we can use coal for the gasification and utilize for this purpose. These are the various methods of producing nitric acid, method for producing ammonium nitrate from ammonia after treating with ammonium nitrate, hydrogen nitrate, and then ammonium nitrate it will be produced. This is our coal to ammonium nitrate flow diagram. It's shown over here. See, whatever year it is notified in the blue, like a fly ash, this entire setup it is now it's being manufactured and supplied. Rest of the technology, it's in we can say some are with type with many foreign players. We are building it. Some are borrowed and some are indigenously developed in this. Few of the technologies are indigenously getting developed. So with respect to again the proposal stage, see gasifier, what is BHL gasifier offers? So presently we have designed the gasifier for 3600 TPD coal equivalent. A single gasifier can gasify per day almost 1125 tons. Gasification can be done. With respect to coal nitrate, we can do up to coal to ammonium nitrate. It is like we could able to do around 2400 tons per day coal equivalent. This project is commercially already it is signed. It is in advanced stage, like implementation is going on. Few of the packages have been awarded and it is getting manufactured. The other projects are in process. Our gasification boiler gasification gasifiers works in 30 kg pressure and the operating temperature is 950 to 1050 degrees Celsius. So these are manufacturing and major equipments in the gasifier island. What are the components? Various components in it had been notified here. This is a BHL gasifier which is indigenously developed and patented, that had been shown here. This is a BHL pressurized fluidized gasifier alone. These are coal, how it is being fed. So this is glimpses of the MOU signed with Coal India, where we are 49% equity holder in establishing the project as well as the technological provider for building the project on build and operate mode. We are going to build this coal gasification unit at Orissa. So roadmap of coal to chemical business. Here, based on the National Coal Gasification Mission, BHL is continuously working on various technology to develop as well as continuously tying up with various collaborators to supply the entire package by BHL. In the upcoming days, whatever the target had been set by the Indian government had been taken in a true spirit to build those things, which it brings sustainability with respect to the implementation of technology as well as delivering the requirement in a cost-effective way. So for that, actually, this entire package it would be module basis where we could able to supply these projects in 42 months. We could able to build this coal to chemical business based on the various capacity. Whatever capacity I had shown earlier, it can be built in 42 months from the rate of LOI. So summary. So gasification is indigenously developed by BHL. By gasification of coal, we find the alternate usage of coal rather than using in thermal power plants alone. And in turn, we can reduce the amount of import of fuel from across the globe, where our import bill can be reduced. We can reach sustainability in it. By getting the energy in sustainable way, we will increase the affordability, and in turn we can improve the economy of the country as a whole. In this, the capability in we can say that technology need to be developed, the end to end to operate this, people should be more educated, and more job offerings would be there in the coal gasification sector in the coming days. Presently, actually, you would have seen even BHL is recruiting engineers. In ET, more than 400 plus engineers have been called for recruitment. I request all the faculties to intimate the final year students who are completed to apply for this and get benefited. Hope so they will be the contributing member in our company too. Okay, these are the various capacities of our gasifiers, and some of the technology for the purification process. Actually, we are working on it as a company to acquire the technology and develop those things in house. Thank you. BHL is fully geared up for developing the technology itself to meet the coal gasification mission. Thank you. Thank you so much for the opportunity. I open this forum for the question and answers. Thank you, ma'am.
Thank you, sir.
Sir,
Okay, madam.
sir, we are very much thankful to you. Sir, lastly, what you have told that the students can enroll in your organization. So
Ma'am, actually, the thing is that BHL this time we are recruiting more than 400 plus engineers, ma'am, as engineer trainee. Whoever had completed engineering, they can apply through our careers.bhl.in portal. They can write the exams. If they clear the written exam, then interview would be called for. They would be recruited in our role in our company, ma'am.
but no gate score is required.
No gate score. It's a direct BHL exam.
Okay, very nice, sir. I shall inform my students.
Yes, ma'am. Actually, it's a good opportunity. Like based on their interest, BHL is diversifying in coal gasification. We are doing defense sector business, and we are into metro rail, and we are entering to green hydrogen. Actually, almost in the energy sector, in all the fields we are catering presently. So diversification is happening in a big way. The fresh engineers in all the fields, right from civil, mechanical, electrical, E&I, all the fields are huge requirement at KM. So students are welcome to apply in those roles, ma'am.
Okay, sir. Okay, I inform the students. Okay.
Yeah,
sir.
yeah.
Sir,
Any other doubt from the participants are welcome, ma'am. 10 minutes is there. I could able to clarify anything relevant to energy as well as with respect to whatever today's session is there.
Thank you, sir. So, dear participant, do you have any query? Please ask. Participant who have any query, they can ask. Sir is waiting. Okay, fine. So, thank you, sir, for the wonderful sessions. The presentation was really very nice. So, yeah, nowadays, so energy sustainability was really very challenging. Sir has talked how to gasification. It is really very nice presentation. On behalf of Electrical Engineering Department, I would like to extend my heartfelt gratitude to our esteemed speakers, Mr. Magesh Kumar, for your exceptional presentation. Your insight and expertise made a significant impact, and we are grateful for your valuable contribution. Thank you again for sharing your knowledge and making our event a success. Thank you, one and all. Thank you, sir.
Thank you so much, sir. Thank you so much, ma'am. Thank you for all the participants who are patient listeners. Hope so. It would have touched somewhere. If you find any queries, any point of time, you can this one very well approach me. I am there to clarify any doubts are there. Hope so. We'll get connected in future too. Thank you. Thank you so much.
Okay, sir.
thank
Thank you,
you,
sir.
sir. Thank you, sir.
Thank you, sir.
Thank you.
Okay, madam. Okay, madam. Madam, please carry out the session.
Okay, ma'am. I'm just leaving.
Okay, sir. Okay, participants. Now the time for exam. The First of all, we have exam, and I shall send the link in the chat box as well as in the WhatsApp group also. First of all, you give your exam, then you have to attend the feedback session. These two occasions are important and mandatory for this FDP program for getting the certificates, and you have to give the exam as well as you have to attend the feedback session. And one feedback form is also there in your portal, and you have to fill up that feedback form. Unless you fill up that feedback form, you will not get your certificate. So please wait. You can be on the line, or I shall send the link, and you please answer your question. And after uh, 15 minutes, we will be back again for the feedback session. You please join the session. Mandatorily, you have to attend this.